Good afternoon, ladies and gentlemen. My time is 4:35, so I'm going to start. I hope we are refreshed from lunch, and this is the session before last. So I was expecting actually the full house, because the next session, I don't think everyone needs to actually miss that one. Okay, I'm going to introduce Trish Damkroger, and I'm going to just go through the bio. Trish is the Senior Vice President and Chief Product Officer, HPC and AI Business Group, Hewlett-Packard Enterprise. Trish Damkroger joined HPE in April 2022 as Senior Vice President and Chief Product Officer for the HPC and AI business unit. In this role, she leads the end-to-end product strategy for the organization, driving efforts to scale the business to enable the next wave of growth and innovation. Prior to joining HPE, Trish was Vice President and General Manager of the HPC Group at Intel, responsible for setting the technical HPC strategy for Exascale to department-level supercomputers. Before Intel, Trish was the Acting Associate Director of Computation at Lawrence Livermore National Laboratory, leading a group of more than 1,000 supercomputing engineering and scientific experts. She has also served as Program Manager for the Advanced and Exploratory Weapons System Program at Sandia National Lab, where she managed technical programs related to advanced weapon technology. Since 2006, Trish has been a leader of the annual Supercomputing Conference, the SC series, the premier international meeting for high-performance computing. Trish holds a Bachelor of Science degree in Electrical Engineering from the California Polytechnic State University and a Master's of Science degree in Electrical Engineering from Stanford University. Trish, the stage is yours.
Hello. Waking up, huh? Excuse me. Day 2 of the CHP conference. CHPC conference. I'm going to grab some water because I'm choking. Just a sec. So what I wanted to talk about today is kind of where we are and where we're headed. And as Nora said, I have a long background, excuse me, in high performance computing from Sandia National Labs, Lawrence Livermore National Labs, Intel, and now Hewlett-Packard. And I think that has given me a good perspective of being a user and trying to get these systems actually to work and run our scientific codes to, I mean, even before that, writing, applications for it. And then producing the silicon part of the high performance computing, and now that full system view. And so hopefully I can take some of that perspective as we're looking forward of where we're going. So first, I want to start with, where we are today. The journey to Exascale. We achieved that and it was announced at ISC 22. It was, and like I say, people that are part of running an HPC center, they all know it takes a team. It was a team of individuals to get to that 1.1 exaflop between Oak Ridge, AMD, and HPE. It was I don't know if you've heard the stories, but it was down to the very last minute. It was one of those crazy all night, getting the text at 3 a.m. saying we did it, finally did it. So it was a really fun time. But when you look at HPE and its heritage, we acquired Cray a couple years ago, and Cray also celebrated its 50 years anniversary. And one of the most fun experiences I've had so far at HPE, besides coming to these fabulous conferences with Happy and others, is going to Chippewa Falls. So Chippewa Falls is where they manufacture these Cray systems. And there's a Seymour Cray Road. And, it's just like going back to 50 years ago, what it was like. Obviously the buildings are not from 50 years ago, but it was also really fun. I don't know how many went to SC22, to honor that 50 years, we had the Cray 1 on the floor, along with the current system that we're delivering to Los Alamos National Lab. So that Cray 1 went to serial number 1 went to Los Alamos National Lab. Found out they didn't even pay for it. I forget who the first customers were that actually bought a system, but just to show from that, and if anybody knows what a Cray 1 looks like, it looks like something you sit on. So it's a pillar in the middle and it has seats around it. I'm not sure why that design is, but it's pretty cool. To what we're doing currently in our Cray EX systems. And so the current Crossroads systems for Los Alamos, we kind of intercepted one of the racks that was going from Chippewa Falls, the manufacturing, as it was being delivered to Los Alamos. It kind of stopped by Texas for SC. So I thought, that's just it was a great way to show how we've evolved over time and how we've gone from, teraflops to exaflops and why that's important. And I think one of the things that stepping back, a lot of you have been in the HPC community too. I'm looking at Paul and Happy and others. These are tools that are used for people to solve their problems. And even though I can get really excited about that big frontier box that you can see up there, right? It's cool engineering. It's really there for the scientists to do their jobs and to do things like find COVID vaccines and hopefully get to personal medicine and all the other applications, weather, forecasting, all of that these machines are used for, that I get really excited about. So we got to exaflop, and we're also looking at I don't know how many people are familiar with what was required for these systems, but the Department of Energy also required that not only was it a floating point operation, it also had to do AI operations. And as we look forward, one of the things we see is this integration of modeling and simulation and artificial intelligence. So when I was at Lawrence Livermore National Labs, so 5 years ago, we were just starting, the National Ignition Facility is there. The National Ignition Facility is trying to bring the sun to Earth, right? So try and create fusion energy out of water. And they had designed a pellet. So if you look at the hologram, it's about the size of your pinky. And inside, the size of half a strand of hair, is this pellet that had hydrogen in it. And they were taking 192 laser beams. It's 3 football fields, American football fields. Well, I don't know what that is for a true football field, right? As we're watching the World Cup. But a huge, these huge lasers going down into this thing, the size that's less than your hair, to try to get out more energy than they're putting in. And they had done a ton of modeling and simulation to develop the shape of what that target should look like. So it had 192, it was a sphere, 192 lasers coming in from all different angles. And they thought that by doing that, they could implode and explode and they would get the energy. It wasn't working. mean, it was working. The laser was working and everything, but they were not getting to that break-even point. So they said, we have all this data. Let's just run it through AI models. And it came back and said, you shouldn't be a sphere. You should be a cylindrical shape, right? But this went against everything they thought, right? So after I'd left Lawrence Livermore and I came back for a review maybe 2 years later, they finally tried it. And lo and behold, it created the most energy out. They broke break even. And I was lucky enough to go to the Cray user group this past May in Monterey, and there was somebody presenting kind of the latest work and how they have actually started integrating AI into modeling and simulation. I mean, that's the holy grail. It's about getting that workflow. Right now, a lot of people, they'll use the machine for AI at scale. They're supercomputing, and they'll use the machine for modeling and simulation. There's not one workflow that's using all those workloads. So that gets me really excited. And so I think that's where we're going. You'll see a little bit more about that as I continue in this talk. But how do we get from moving, using a supercomputer for doing everything? And I mean, I know some of the great work. I mean, I know when I was replacing AI or physics models with data models because it will speed up and stuff like that. So again, it's just doing separate things. I really think the holy grail is getting to that workload. So let's talk about real briefly about what does HPE bring to the equation. And one of the reasons why I joined Hewlett Packard, as I said, it's that full system provider. So I've been a user. I did the silicon, the compute part. We're getting into GPUs. So I see some of my Intel friends out there, and yes, hello. And they've, I'm sure you've seen their roadmap and where they're going. And we're close partners at Hewlett Packard with Intel, bringing these technologies into a full system. So part of that equation is having compute, network, software, and storage. And that's how you bring a solution together. And those are the important elements of it. So when we look at compute, I'm going backwards. So if you go forward, if you look at compute, you can see this portfolio that we offer with all of our partners. I tell my partners, I love them all dearly. And I'm not going to go through a roadmap presentation for you, but obviously that's a key part of the portfolio to offer. The one thing I do think is kind of cool is at SC, we did introduce the Cray EX2500. And why is this cool? Because it's the same thing that you can get from the Frontier into a single rack. So it's being able to, instead of needing the 4 racks for a CDU to actually run the machine, you can get it per rack, which, if you want to try out Exascale, type technology, I think that's kind of fun. But again, I'm not going to go through roadmaps. Cray also and HPE have the full software stack. And this, I think, is really important when we talk about how do you run a machine, right? At Lawrence Livermore, we had a lot of our own proprietary applications. We had TOS and different ways, but we all use Slurm and, for resource management, et cetera, right? But with the Cray acquisition, HPE was able to add in the Cray programming environment and that full software stack. Some of it is HPE software. A lot of it is other vendors or open source. So it's a complete stack. You can run it. For example, we're delivering the El Capitan to Lawrence Livermore, and they want to use their own user management system. That's fine. We can integrate it in. So it's really up to you of what you want to use. And we just try to make it so that you have those options. A lot of people want to use one API from Intel. great. We're working with them in the Cray programming environment to figure out how to make sure we're open and able to work with all of our partners. We do have a Slingshot, which was introduced in the Exascale machine. It's only available today on Crays, but it's being moved into our full product line. Slingshot is a high-performance Ethernet fabric. It's pretty cool, actually, that we're using Ethernet open standard as the basis for it. I think, but obviously, if you want Mellanox, we offer fully Mellanox. A lot of people just want Ethernet. Great, that's fine. It's really about the optionality and the versatility that the customer wants. And another key part is storage. We have Cluster Store that came also with the Cray acquisition. We work closely with GPFS and have our own instance of that, but we also work closely. I saw VAST here. So we're working with VAST, we're working with Weka.io. Again, making sure that we can support whatever the user really wants. Looking forward, we are working with Argonne National Lab and Intel on Deos. So that's our object store. And I am excited to see how that, in fact, Nick Dubé, I don't know if you know Nick Dubé, and I were talking last night, and he was going to head out to Argonne National Labs. And right now they have Deos up and running, but then also they're starting to bring in Aurora for the system. And we were kind of talking about, okay, I really want to see how this is going to scale and how this is going to work. So, but I do think Deos it's very interesting. It was a fun group that I was managing when I was at Intel. Excellent technology. And then the last thing that we offer, which when Intel, I have to be careful here. I probably should say this, but when Intel wanted to kind of get into the systems business, this is the area that they really didn't have, was the services part. And even in the Aurora system, Intel is the prime, but HPE, it was Cray in the original contract, is doing the services. And just because HPE has a long history, it's called Point Next. I don't know why, that providing services, not just break and fix, but the full gamut, especially with Cray systems. We have put people on site, we have local teams, et cetera, to make sure that the system is up and running all the time. If you do not have the expertise, or you want help. So that is why I joined HPE, because, like I said, it's got that full portfolio of from compute, software, network, and storage, along with the services. And it's been fun. So it's been there 7 months, and HPE systems are hard to bring up. In fact, Nick was telling me about how he first came to CHPC and worked with Happy with the Sun system, and how he came and they were just boxes and mislabeled cables, and he just talked about how he fell in love with CHPC and he wanted to make sure that he didn't leave until it was working. And I think that that's what's been fun about being able to be part of when you're actually bringing up a system. It brings me back to those days at Lawrence Livermore when we really, it's a team. And I honestly, at that point, I never brought up a system. When I was at Lawrence Livermore, I was always on the software side and the research. And then, I was running comp. But I would get the daily reports, and how many runs have failed and all that. And so it's nice to be back in that action of really bringing up systems and getting to live through those challenges again. One of the things he did say, Happy, though, is he definitely wants to be the keynote next year. And he wants to help bring up your next system. So you should hold him to that. Because I do think one of the things we were talking about is when you come to CHPC, you come to South Africa, you're so energized by the people and the talent and the teamwork. And I came in 2018 and did the keynote, and when Happy asked me to come back, it's a long flight, but I thought, oh, but this is so fun, right? So anyway, one of the joys of getting to be part of that full solution provider. So let's look forward, kind of where are we going? I know Olivier showed you some of these slides today about our AI at scale portfolio. We've taken our modeling and simulation, and we acquired a company called that was named Determined AI to really do machine learning at scale. And we have some customers that we're working with to do that. And it's cool, some of the areas that they're going into and what we're going to be able to do by using the full supercomputer to do AI at scale. But when I really look forward, and we're saying, where are we going after Exascale? This is where we believe we're going, and it's really the system of systems. So today you have the Exascale supercomputer, and it doesn't matter if you have an Exascale system or not. You have that technology that we're using today. And the next step, we see people will want a couple Exascale. You know, there's going to be probably not a big change in the technology to get to the tens of Exascale that we're expecting. But where we really see it going is a federated workflow. So remember I talked about how we have modeling and simulation we do on machine, and then we'll do AI on a machine. We're really talking about how do you integrate those workflows and have modeling, simulation, data analysis, artificial intelligence is all part of the same workflow. And as we move even further in time, so this is today through time as we're going out, it's that system of systems where we can maybe, I know at SC there was a panel, I don't know if Dan and Addison are here, that talked about composability or not composability. Are we ready for that? But, you know, imagine when you have things at that edge all the way to the cloud, you're going to have compute all along those stages as we go. And that's where the whole systems of systems comes into. So this is the way we view it. So let's just start at one. So up at the top, we've got to write applications, make it easy for individuals to use the HPC system. That's the user, that application developer, the scientist. So that's the very first thing. We have several programs in the lab working on program productivity. You know, how do we make it so that people that maybe if you graduate with a Python, and you know Python, you'll be able to use an HPC system. Then we go to the second element, which is the edge. So we envision you'll have edge devices all the way through to the cloud. And I think, a great example is the square kilometer array, right? The amount of data, we were talking about to some of the folks that, 2 terabits per second of data, and 98% of it is noise. So how are you going to filter at that edge so you're not sending all that data back to the supercomputer? But that's just one example. In the Department of Energy in the US, there's a ton of examples of, even NIF, the National Ignition Facility I was talking about, where they're producing a ton of data. And we need to put compute at that edge, maybe the right kind of compute. Whether it, and probably we expect it will involve AI and inferencing at least at the edge. Okay, so then talking about AI, let's go to 3, where we have that data foundation layer. And we believe that we're going to, in order to decide again what data is coming, is we've really got to look at trustworthy AI. And this means it has to be fair data, which is findable, accessible, interoperability, and reusable, right? And so we're going to focus, we have a project where we're focusing on the metadata and trying to automate more and more of those processes. So then you move to 4, I'm looking at my little machine down here, heterogeneous computing. I don't think this is anything new. We're talking about CPUs, GPUs, FPGAs, silicon devices, whether it's Cerebus, Graph Core, there's a lot of options out there. And how do you make sure that your application is running on the best hardware for that application? So we're working with some, looking at system architectures and software to extract the computation that is being used and why, doing the whole open fabric attached memory libraries, looking at job placement. And the other thing we're doing because where there's not some solid AI benchmarks out there, and so to really know whether the GPU or CPU or other type of silicon devices are the right devices, we want to make sure that we can establish the benchmarks for the community. So we're working with the community to look at that and establishing how we compare AI. And then you go to, that was 4, so you go to 5. I had a discussion today with somebody who's like, I don't want to go to storage. I want to stay in memory. I don't want to take that time. We have to have that memory hierarchy. We have exciting silicon coming out with HBM, DDR. We know how much you can put in your cache. But we're looking, that's one of the projects we have in our whole storage portfolio is Deos, like I mentioned earlier, really taking that edge environment into account also, and offering more than block storage is what we have today. 6 is our investment in interconnect. I talked about Slingshot before, but where is this headed? Where does Slingshot need to go? Obviously, it has been successfully deployed on Frontier, on that Exascale machine. It still needs a lot of work in the software stack, and we're working on especially how do we move AI and where AI is going. Because that's still, we know kind of what we're doing now, but where is AI really going? We've done quite a bit of work with silicon photonics and that integration into the whole network and fabric, part of the whole CXL world with our Gen Z stuff being folded into it. So we have a number of projects looking at kind of what is the future of networking fabric. And underlying all of this is security. So that pervasive security. And again, when you look at this framework, it's really got to be that edge all the way through. And security, it's important that we have not only that, so I say device through application, but also data sovereignty. So I know this is important in many countries about how to maintain your data. And we also have a number of projects on zero trust security constraints. So again, these are where we see the future. We have research and ongoing projects in all of these different areas. And one of the things that makes this ecosystem stronger is when we partner and work together. And so if there is an area that you see that you're interested in getting more information or you'd like to join in, this is all open. I mean, there's none of this work is proprietary. It's, I came from the Department of Energy Laboratory where everything had to be open source. And HPE is definitely going that route about opening everything up. We'll have a few announcements coming up about some of the things that, have been said could be proprietary. So stay tuned. It was supposed to be announced at SC. So I'm just tell you that. So I think, so again, it's about partnerships. So if there's areas that are really interesting to you, please reach out to us, because And if you disagree, even better, let's have that conversation, because that's the way we're going to get better. And again, it's about solving big problems with this infrastructure. It's not about, building the biggest machines. So that is the future. So I just kind of want to bring this back into where we think one of the other elements that we have. So we're talking about this big edge to cloud future. We do have our Green Lake for HPC today. And it is a growing portfolio for us. Last year, we closed out our fiscal year at the end of October, and we had a 30% growth in our HPC, our Green Lake for HPC, well over $100 million in orders on that. And just some of the, we have a number of success stories that you can go to about where GE is bringing it in, and they're really looking at accelerating, their scientific discoveries, obviously, but it's also that whole digital twin and looking at how do you create that digital twin to make sure they can move faster. So the things that you can do right now with Green Lake, we can talk to you about where we are today and then and where we're going. So one of the announcements that we made at Cirrus was that we think is so important is allowing people to try things out. When I talk about Cerebrus, GraphCore, not everyone wants to buy one of these machines, but to have access to it and try it out, that's pretty cool. So we're going to put, and this will be in beginning of next year, bring up a system where, and we're still figuring this all out. So this is not, something that I can offer you today, but like I said, in probably February timeframe, where you can, you want to compare even say your A100 to the new Grace Hopper or PVC or the AMD GPU. We'll have all those systems there. And so you can see which one works best for your workload, right? You want to try Cerebrus GraphCore. So this is a Nick Dubé's project, and he's putting this together. And like I said, we hope to have this a base set, and we're doing this in partnership with Intel, NVIDIA, and AMD. This is not HPE going off and trying to do anything. It's not, it's really opening it up. It's also going to be really good for the software ecosystem so that we can see what, one API, pushing that along is important. Like I said, we're working closely with that team, but also bringing along all of the software infrastructure, because we got to help our programmers and our users, because right now it's really hard. So that's part of the intent. That's kind of my backside, my goal of this, but also, to allow you to try things out and figure out what you like. We're talking about, and this would be a great discussion if you know Nick, kind of having a subscription service to it so that he can continue to bring in the latest and greatest, working with the vendors, and you have that access to continue to try different things. So stay tuned. It's kind of a sneak peek of some of the stuff that we're doing moving forward. So when I wanted to kind of just put this all in perspective, so we talked about where we are today with that number one supercomputer. It's Exascale, it's moving forward. We also talked about, having all those different components working together and having kind of that one person or one company to work with. But it's not just about that too. It's really about bringing the community together. And with HPE, with its acquisition of SGI and now Cray, we've really brought in amazing talent of people there that the depth is just amazing. A number you about today is, I talk about Cray being 50 years old. We have people that were part of that still working in Chippewa Falls, right? So part of what I need help with is that bringing along that next generation of HPCers. And that's another thing that I'm really excited about, all the students that I'm seeing here and all the energy. So I'm a huge fan, as you can tell, of HPC. I'm also a huge fan of HPE and what we can do, but it's the users that is why I'm a fan of it. And so I want to open it up for questions. I'd love to hear your views of this. What do you think? And I know I have a couple minutes. Happy, right? Have a couple minutes? Okay, Jean-Laurent. I don't know if we have in the mic. Sorry. There you go.
Yeah, I'd like to understand. So I got the concept, but to me, in the future, the problem is moving data. How do you plan on fixing that?
I think great question. And so we are doing a lot of our work so HP, one of the, Cray, I always go, it's interchangeable, right? We have the data management framework, which is this underlying infrastructure that is about the movement of data right now, it's between compute and storage. We are expanding that and looking at, again, that metadata, but and also APIs, and how do you look at exactly that data IO bottleneck challenge, right? We've gone from compute challenge, memory bandwidth challenge, and I agree with you, IO is our next big hurdle that we need to get through. We are doing a lot of investment in Slingshot with the congestion management and other aspects to do some of that, but we still need more work there. Whether it's CXL, there's a lot of things that we're looking at and have projects working on along those lines. Anybody else? Do you have one of those? Okay. Perfect.
Hello, can you hear me? Is there not an opportunity for an eighth component here, and that is energy awareness? Particularly when you talk about this disparate compute and edge, knowing what to do where, when to move the data or when to crunch it, to me, that's a pervasive layer alongside security, figuring out where energy is best spent.
I agree. Sustainability is so important, and prioritization of that. I mean, you will see that Frontier is number one in the Green 500 too. So that is something we build in. You can do the direct liquid cooling with room neutral water, et cetera. But I think a couple things there. Again, it's data movement, like where to put the data with compute. I believe that putting compute as close to the data makes sense. That's why you would put it at the edge, et cetera. And I don't think too many people in this audience would disagree with that. That's kind of basic, right? But when you look at, and I think it goes very much with what Jean-Laurent asked too, is that whole data movement, keeping data, only moving what needs to be moved. That when we talked about having the data foundation, so up there where we have that machine learning platform that really builds that community to help you say, where should you do that compute? I mean, that is, we do have projects looking at exactly that. So with this type of an algorithm, with this application, it will work best on this, GPU, that 8 GPU box where you need, or CPUs, or doing that work and investigating exactly that. Yes.
Simple question. You're like the first person I heard who didn't mention quantum. And I'm just like shocked.
Well, we are looking at quantum. I was at, I don't know if anybody else, I was at a conference. Well, Ava was there. I don't know if Ava's in the audience. And Jack and Gara runs it. And it was just kind of like one of the presentations was quantum. Is it going to happen in our lifetime? And I have to believe, I think it's kind of like fusion energy. It's always been 50 years out or 10 years out or whatever. I think we are making huge strides in making qubits. I was very involved in the Intel effort that was doing that, and kind of looking at how to do it differently. I still think we need to figure out what it'd be used for.
I have to say, Trish, I completely agree with you. The realization does not live up to the venture capital hype that's going into it, apart from a few niche applications in defense intelligence and obviously networking for comms.
Right.
Quantum comms, yeah, that will happen before I'm dead. Someone running molecular modeling code on a quantum computer, I'll be long dead before that ever happens.
Right.
Most of my customers can't even program for a GPU, let alone a quantum machine.
I know. How are we going to do quantum?
It's not going to happen.
I mean, I hope it happens. I don't know if you are a big believer or not. I think you're a physicist background, so you're better than, I'm an engineer. But
Well, being someone also in fusion, but tokamak physics, and you didn't really mention that, but I'll let that slip. But I actually, same comment with quantum, probably not in my lifetime, but hey, it's going to happen, but I don't see it happening in 20 years.
right. And that was kind of the takeaway I took after this big discussion at this conference over the summer. I mean, I was always a little hesitant, but people that have been working with it a lot closer than I have, that was kind of the takeaway I took. But I'm not saying there could be breakthroughs. We do have a program, but again, we're not developing quantum. It's more, we're going to make sure that we work with people so that we can integrate it into a system and understanding that. But we're not developing qubits or anything like that. Way back there.
Thank you. I can see the infrastructure. I can see the data, I can see the techniques, the methods, the tools in there. Yet the world that we live in, many communities are affected in different ways in how they benefit from technological advances, factors like legislations and many others. Is there anything that features within that framework that could accommodate some of those other communities which are left behind in benefiting from the advancement in technologies?
So you're talking about integrating other communities with our kind of better. I missed that first part.
What I see there is the infrastructure, the techniques, the data, the methods, the tools. The users, those are presumably are experienced users.
Got it.
People at the top end of the spectrum. Yet there are a lot of communities around the world who probably wouldn't fit within that and could be affected by other factors. Is there any consideration for that?
You know what? I love your question because I'm actually kind of embarrassed because this is such an HPE-centric view. we don't have our users in here, like you say, we don't have, and that is great input of how we're going to bring in that those other communities and how we need to help them. So this is the way HPE is viewing what we think is the future, where we're making our investments. But I think you have a great point that we are, you know, absent the users for sure.
I just wanted to see if I could make the microphone work, but now
Good
that
job,
I have,
Dan.
Thank you. It does work. It's a very cool system. However, real question, what do you see the market for Exascale shaping up like? I mean, after PETA came about in 2008, all of the systems became PETAs. Do you see the same thing with Exa?
So, I mean, you know me, I'm always going to be too honest, too blunt, right? Exa, people are doing Exa and governments will pay for it because it's national security, economic security, right? But the reason why we have such big systems is because we need compute. I mean, the one thing that when I was at Intel and what I hear at HPE and even at Lawrence Livermore, the data is requiring more and more compute. So I don't care if you call it exascale, you know, I mean, that was a term to get funding, right, from our governments. And they came up with all these applications that required it for national security. But the bottom line is I do think compute is going to continue to grow. And we see, and when you look at AI and doing AI at scale, it requires a supercomputer. I don't care if it's, you know, 1 petaflop or 100 petaflops, that's what we're seeing. You need that dense, tightly connected supercomputer to run these workloads. You disagree with me, Paul?
No, I've been trying to think of something to disagree with you, but I haven't been able to come up with it. No, I completely agree with you. I mean, we've had this debate in the UK currently on whether we deploy an exascale system or whether we deploy more of a federation of large enough machines. And unless you've got a GDP that's big enough to drive the leading edge for the rest of the world, it's a complete waste of freaking money. An exaflop machine on the floor. I can't put it any other way.
So I might disagree a little bit with that.
Someone has to do it, right? Someone has to do it to push the envelope, because we'll be using those technologies tomorrow that we benefit in everybody.
Hey, Paul,
you've got that disposable budget.
Real quick, did you say the same thing about petascale?
No.
Okay.
Exascale is different, right? It is stupidly expensive at the moment, and most applications can't get anywhere close.
No, I agree.
It's just going to be used by n much smaller jobs. And the infrastructure and the shag that you have to go through to deploy that is not worth the return unless you have a human good mission to drive the technology forward for the rest of the world. Fortunately, the US can afford that. And so they do that, and we all get the benefits maybe in 10 years' time, because we'll be using some of those technologies. But for most people, because what would happen in the UK if we deployed an exascale system like that, many other projects would become defunded.
Well, that's the problem.
And that's
it is
the problem.
a large amount.
If you have a finite research budget for your country, deploying exascale would defund many other projects, which would give you much more value. Yeah, so for the most of us, exascale is a luxury that is not necessary, because 5 200 petaflop machines with different technologies in different centers driving different work would be much better than one narrow exascale machine in one place.
So what I'm saying you hear is that federated, yes.
It doesn't matter what the size of the unit is, it's the federation, it's the workflows, it's giving dynamic flexible platforms for your researchers really that count, not the size of it. The HPC community are finally maybe getting over the size thing.
Right.
Still too male dominated. I think that's the problem. Get rid of the size thing, and we're moving.
So I know I have time, but just one quick. I think that when I was at Lawrence, I mean, there's a lot of us that talked about, really, do we want that top 500 run? Is that the right thing that we should be measuring on? Now, I like it, obviously, because, you know, for us at HPE, but I get where you're coming from. I totally do. And I think we are aligned completely in where we're going. So how, okay.
I think that's.
Okay.
All right, so I have to beg to differ a bit, but again, I come from Oak Ridge where we do have like all these top computers, but the reason why I'll say a little different is, you know, I deal with a lot of the bleeding edge applications, Workbacks, which is the latest, you know, Gordon Bell winner who, you know, I work with, and many fusion codes. And, you know, when I look at it, like recently we started working with GE, and I think you mentioned GE. So they're actually running this wind turbine application. So one of the things that I really like what you said was IO is so critical. So I became someone who no one cared about like 20 years ago, and now it's like everyone comes to me because IO and data movement is so important. But you know, when I see GE and they're running full at scale, I'm seeing people who are running hypersonics at full scale. What I'll say is there are a lot of users who really need it, but you know, and again, I get it that the majority do not.
Right.
But there are enough, and when I'm seeing GE where they are actually scaling this to all frontier, that's exciting to me. So I think there's enough of an audience, but it's not like the general audience. So I get, Paul, what you're saying, but I'm just saying there are enough. So
there's a few
we
in
have a
yeah.
reason to exist at Oak Ridge.
Funded environment where you've got enough money and a big enough GDP, most countries unfortunately don't have.
And I agree with you. I just happen to be from kind of a rich
You have
place.
one that can. And I would say, you know, I agree with you that I think like Lumi, that large system at Lumi, offering it out to others, that's where we need to go. And it is kind of more that federated approach where you can have access to the compute that you need to have access to.
Just because it's empty, they don't have enough users.
Okay.
Right now. But yes, I think
3 minutes. So,
so I love the debate, and I really appreciate. You know, I want to put out ideas, and I want to have conversations. Again, HPE is about having those conversations, partnering, creating the community, and moving forward. That's what this is all about. And I've been in HPC now for over 20 years. I honestly, when I left Intel, I was like, I am done. I'm going to go to a CSP. I'm going to go make a lot of money. I'm going to, you know, go do something different. And my job offers were so boring. I couldn't imagine. So I was like, I mean, it's in my blood. You know, they talk to me after this job. I go, oh, okay. So HPC is cool. Help me get that out to all of our next generation. And let's work together to make this a success. Thank you. I don't know. Thank you so much. Thank you. Let me just.
ladies and gentlemen, thank you so much for your attention. I'll be giving away for Dr. Stolle for the next session. I hope you've been waiting for this moment. Thank you very much. Can we give Trish a hand up?